In this video, I'm going to give a quick overview of the Explore Coding Kit and build a few projects to show how it works. You'll just need the kit and an Apple or Android tablet or phone. Let's get started. First, build Project 1, which uses the U33SC controller to turn on different lights. It's easiest to snap in the large pieces like the battery and the SC controller first, and then move on to the smaller parts. Be sure that when you snap in the LEDs, the positive end points towards the SC controller, because diodes only allow electricity to flow in one direction. Also, whenever you build a circuit, make sure the switch starts in the off position. To start coding, install the SnapCircuits coding app on your phone or tablet. Once it's installed, just turn on the circuit, open the app, and tap the switch once your controller shows up on screen. If you have any issues, try turning Bluetooth off and back on again, and then restart the app. Control mode lets you turn the SC controller's snaps on and off remotely. This is a great way to play with your SnapCircuit kit, or to learn how more complicated circuits work before trying to code them. For the SnapCircuits Code Journey kit, there's also a rover control mode. Now let's move on to some coding. This is the bot code screen. The screen has four main sections: the library, the workspace, the display, and the control bar on the bottom. To add a command to your program, drag the icon from the library into the code area, and to remove a command, simply drag it anywhere out of the coding workspace. Let's say we want to turn on the light at snap D1. This means we should drag the D1 command into our code. Watch when the code is run, the D1 snap turns on, causing the first light to light up, and then turns off when the program stops. Now let's make the rest of the lights turn on in sequence after the first. Notice when you're running these commands, text appears in the code display corresponding to your blocks. This is what the code looks like that most programmers write to make computers do things. Something trickier to try with this project might be to turn on two lights at a time. For this, we would need to turn on the light for a long time with one command, but then we need another command to turn the light off. To change the amount of time that the light stays on, tap the block to edit it. You can turn the snap on for any time between 0 and 100. To keep the snap on after the command, tap the infinity button. To turn the snap off, add in another command with a time of 0 to reset it. Now that we can turn a light on for a long time, we can turn on more lights in between. Use the same idea to turn on and off the D2 snap. Great, now the lights both turn on, but I think they could be on for a bit longer. For this, we use a wait block after the light turns on. The wait block is a control structure, which is just a fancy way of saying it changes how the SC controller goes through your commands. Let's drag one of these in and run it. Since we have a program that does what we want it to do, tap the Save button to save your code and type a name so that you can easily recognize it. One last thing you might want to do is make the lights flash repeatedly instead of just turning on and off once. For this, you can use the other control called a loop. Drag the loop into your workspace and put your saved code inside it. This repeats the code inside the loop for however many times the number in the box says. For me, I'll put 3. Another way to make programs is the Blockly section. You can do all the same things as in the bot code section, it just looks a little different. Here's a project you can build to control the fan and lights with code. This program turns on the D2 snap at low power, making the motor spin slowly and the LED light yellow. The second command is another D2, but this time with high power, making the fan spin faster and the light brighter. The third command turns on the D1 snap, reversing the flow of electricity through the motor and the LED, making the LED red and making the motor spin in the opposite direction. Here's a project that really takes advantage of the code. In this project, you can use the SC controller to control the U2 alarm IC, which lets you make 4 different alarm sounds. The first alarm sound plays when the current flows into the middle snap of the U2 module. This means that you can play the first sound by just turning on snap D1. The second sound plays when current flows into both the middle snap and the bottom snap of the alarm IC. Then the second sound plays while snaps D1 and D2 are on. The third sound plays when current flows into the upper and the middle snaps of the alarm IC, so snaps D1 and D4 have to be turned on. The fourth sound is a little different. This one needs current to flow into the middle snap, but then out of the bottom snap. This is where the red Q2 transistor comes in. When the D3 snap is off, Q2 blocks current from flowing through it. However, when the D3 snap is on, Q2 allows current to flow from the bottom snap back to the battery. This means that snaps D1 and D3 have to be on to make the fourth alarm sound. This code on the right goes through all four alarm sounds by just turning on the D1 for the entire program, and then turning on each of the other snaps individually. Things like this are where the code is really handy. Without code, you'd have to flip individual switches to get each sound. You can experiment with this project to see if you can get the alarms to play in a different order or for different amounts of time. This last circuit demonstrates most of the things your set can do. See how the code gives you so much more control over what the circuit does. I hope this gives you a good starting point. Remember, you can always find more information in the manual. Have fun and thanks for watching.